So good evening, everyone. Welcome to the session. So we'll be continuing our domain analytics program on hospital analytics. As discussed, we'll be going for the rules-based method today. Okay, rules-based method, decision tree. So today we'll be seeing decision tree. Let's see. So now what is a decision tree? Decision tree is a supervised algorithm and can be used for both regression and classification. So it works for both continuous values and discrete values. And if it gives us prediction based on this method, rules based method. So how does it work? Okay, let us see. So now in a decision tree, there are terminal nodes and there are non-terminal nodes. Under non-terminal nodes, we are having two types of nodes. One is root node, another is branch. Terminal nodes are also known as leaf nodes. Okay, these non-terminal nodes, okay, they are used to make local decisions based on the local information they possess. So each of these nodes is used to make some decisions. Okay, it is used to make decisions. So in each node, some decision is made except the leaf nodes. In root node, a decision is made. In this branch node, a decision is made. And this terminal nodes, they are the final decision nodes. You can see. Now for this, so we are talking about rules. What are rules in this? The path from root node to a leaf node is known as a rule. So there will be multiple paths in a single decision tree. So all these paths are various rules of decision tree. So a path from the root node to a leaf node is classification rule. Okay, and we, as we discussed, there is root node, decision node, or branch node, and leaf node. Three types of node we have. So how do we build a decision tree? Okay. So first of all, we'll have to select a variable, okay, which we can split at the node. At each decision node, we'll have to select a variable by which we can split that node, okay. And we'll also have to select the value of the split, okay. So which value we are going to split also we will have to find, okay. Also, we have to determine when to stop. Decision to stop also is very important in decision tree. Okay. And also, last, we'll also have to decide how to, give label or how to label this terminal node or leaf node. Now, this decision tree is also known as greedy algorithm. Decision tree, also known as greedy algorithm. It is known as a greedy algorithm, okay, because it will not stop unless it reaches a leaf node. Unless we are stopping it using some stopping criteria, it will not stop unless it reaches a leaf node. So because of this reason, it generally overfits. If you are not providing a stopping criteria, it will overfit. Okay. Now this greedy algorithm, it is a basic algorithm where the tree is constructed in a top-down recursive divide and conquer manner. And at start, all the training examples are considered to be candidates for root node. Okay. And attributes are supposed to be categorical. All the attributes are supposed to be categorical. If they are continuous values, we have to discretize them in advance. Also, the input data is partitioned recursively based on selected attributes, and test attributes at each node are selected on the basis of some heuristic or statistical measure like information gain. So we'll be discussing about information gain as well. Okay, so the basically decision tree is known as greedy algorithm because it will go on finding all the nodes until it converges with a leaf. Now there are certain conditions for stopping of partitioning. Okay, one of the condition is if all the class, all the category, all the samples are having same class. All the samples in the node are having same class, will stop. Okay, this will form a leaf node with the one class it belongs to. Will also stop if there are no remaining attributes. So this is automatic stop. Okay, we are not stopping it manually. So it automatically stops when all the samples in a node are of same class or all the attributes have been used for partitioning. Okay, or we have no samples left to partition. Okay, these three conditions, if they are coming up, okay, the decision tree will not, partition further. Now we are talking about entropy, information gain. So if we are studying about information gain, there is one more term which comes up is entropy. Okay, so they are closely related. So let me tell you what is entropy. Entropy is the measure of disorderness. It is the measure of disorderness in the data. Okay, it is the measure of disorderness or impurity. We can even call it impurity in the data set. Okay, so we need to find this entropy for the output values of a training instance. So we'll show how to calculate this entropy as well. Okay, so here if the entropy is or the output values are 50-50 split. Okay, so in each decision tree, in each node we are making some decision and we are splitting our data. So this data is 50-50 split. 50% data here, 50% data here. We call it impure splitting. And here the entropy will be 1. If it is 50-50 split, entropy will be 1. Okay. If it is 100-0 split, okay, entropy is 0. Okay. And if some percentage of split, we'll have to find the entropy. Like 25% and 75% if it is split, 25% and 75% if it is split, the entropy is 0.811. Okay. And information gain is nothing but entropy before split to entropy after split. So I want to find the entropy of this. So first I'll find the entropy of this before split. Okay. Minus entropy of this after split. So and the information gain is based on decrease in entropy after the data set is split on an attribute. Okay. And we want here to construct a decision tree, okay, which returns the high information gain. Okay, we construct the decision tree. So in each attribute, we want that attribute which returns the highest information gain. Okay, if we are doing this, we'll form the most homogeneous branches. Now, what is information gain or what is entropy and how do we calculate it? So we discussed entropy is the measure of disorderness. So how do we calculate this? Okay. So this is the formula for entropy. E is equals to summation of I equals to 1 to m negative of this pi log 2 of p. Okay, so this is the entropy before split, entropy after split. Okay, it is summation of j is equals to 1. Summation of j is equals to 1 to v dj by d absolute value of this into, okay, we'll get the same formula here, entropy of dj. In this case, we'll be doing entropy of dj. Okay, so we'll show you an example how to calculate this. Now from here, in this information gain will be entropy before minus entropy after. Okay, this way we calculate the entropy or information gain, we can say entropy and information gain. So let me just give you the short version of this. So entropy before will be summation of I equals to 1 to m. So total number of m is where m is the total number of you can say record. Okay, pi is the probability of record having a certain category. Then log 2 pi. Okay, and after will be summation of j is equals to 1 to v dj by d, and then again summation of pi log 2 pi. Okay, whereas this is for the original data set. This is the data set after split. So this data set will be split into two more data sets. This is one of the data sets, dj. Okay, this is d, this is dj. Okay, so this way we calculate the entropy before, entropy after, and then we subtract it to get the information gain. Okay, for that we just do eb minus ef and we'll get the value. Okay. So what are the advantages? What are the advantages of uh, decision tree? Okay. Now compared to other algorithms, decision tree, they require less effort for data preparation during pre-processing. Okay. So very less pre-processing are required for this. Okay. It is very robust. It can take care of pre-processing, most of the pre-processing itself. Okay. And the decision tree does not require normalization as well. Okay. No normalization or scaling of the data is required. Missing value in the data are also missing value does not affect the process of building a decision tree also. And the decision tree model is very intuitive. Okay. And it is very easy to explain to technical teams as well as stakeholders. Now, why is it so easy to explain? Okay. So with decision tree, we'll get a visualization where we can see how this decision tree is splitting our data. Okay. What are the various entropy values and all details also will get. Okay. So this way, it will be very easy to explain the decision tree to technical teams or stakeholders. Okay. Anyone will be easily understanding if they just see this visualization. Okay. They will be able to understand what is up. So it is very easy to explain to others. Now, what are the disadvantages? What are the disadvantages of this decision tree? So decision tree has a disadvantage if a small change in data happens. Okay, there is a large change in the structure of data of the decision tree. Okay, the whole decision tree will change if there is a small change in the data. Okay, thus it is very unstable in that sense. Then, for a decision tree, okay, the calculation can be very complex compared to other algorithms. So it is a very complex, you can say, model. And due to this property, it's generally overfit. Now, decision tree also involves higher training time in the model. Okay, it takes a very long time to train the model because it will recursively, do the training. Okay, then there is decision tree. Training is relatively expensive as the complexity and time taken are more. Okay, so it is relatively expensive based on computational burden as well as time. It will take more computational burden as well as it will take up more time to give us a solution. Time also it will take. Okay, the decision tree algorithm is also inadequate for applying regression and predicting continuous value. Okay, so I told you it can be used, but it doesn't give us good results when it comes to regression. Okay, so generally we require discrete values for input as well as output, but it can be also used for regression. Okay, now for discrete value, values, how do we decide? Suppose in the leaf node we are having multiple classes we are having in leaf node. So if this is the case, we'll take the class which has majority in this node. Whichever class is having, we'll take that class as our output or our leaf node. Okay. Now if you are having continuous value, we'll take the average value of all the records. Average value of all records will be taken. if it is a case of regression. Okay, so here regression might not perform that well, but still we can use it for regression analysis as well as classification analysis. So basically, before going to the use case, let me just tell you the whole process again. So basically, we will be having a data set. And in this data set, we'll be having few attributes. Suppose we are having x1, x2, x3, x4, and y. Y is the output. Rest are the inputs. Because this is a supervised model, we will be having a label data. So we will be having an output and input. Okay, here the inputs are required to be discretized. Also, output should be discrete. Okay, if you are considering classification. Now, first of all, we'll have to look for the entropy of this. Entropy of this table. We'll have to find the entropy. Okay, so we'll use that formula, summation of Pi. Here. Okay. So after finding this entropy, that is log here. After finding this entropy, okay, we'll find which of these attributes, okay, will give us a split in which we are having the highest information gain. So we'll calculate the information gain. If we use this as our attribute and we are splitting, this is having how much information gain. Then we'll test for x2, then x3, then x4. Okay. So whichever of these, suppose x1, x2, x3, x4. Of this, suppose the highest information gain is given by x4. Okay, so the root node will be x4 now. And x4, according to its categories, will be split. Okay, if it is having two categories, it will be split twice. And again, we'll have the data set after split. Suppose x4 has two categories. Okay, suppose male, female. So this will be male, this will be female. And again, except x4, all the three columns will be here, x1, x2, and x3. And also y. Here also x1, x2, x3, and y. Now again, we'll do the same thing as we did here. Again, we'll find the entropy of this whole table here. After finding the entropy for each of these columns, we'll again find if we split according to this attribute, or according to this attribute, or according to this attribute, what will be the information gain? Here also we'll choose the one with highest information. Suppose here x1 gives us the highest information gain. Okay. Suppose x1 gives us highest information gain. So here we'll choose x1. Similarly, suppose here x2 gives us highest information. We'll choose x2. Then again we'll split. So for x1, X4 is already gone. So for X1 also, suppose all are binary category. So now we'll have X3 and X2. X2 and X3. Here we'll get X1 and X3. Okay. Again, we'll find the highest information gain for which of these two we are having. Okay. Suppose X2 here. Here we are having X1. Okay. Then we are left with just one. Okay. So this will be a leaf node. Again, here this will be a leaf node. This will be a leaf node. This will be also a leaf node. So this is how we do decision tree. Okay. So this is how a decision tree is built. Okay. Once we find this leaf node, okay. So this leaf node will have categories of Y. Okay. So based on the majority category of Y, whatever is present, we'll place it this category. So suppose Y has category A and B. So suppose here A is greater, A will be here, B will be here, A will be here, B will be here, something like that. Okay. Whichever is greater at this node, okay, whichever is having majority will be placed in this node. So this way we calculate, or this way we build the decision tree. Now here, after we have built the decision tree, we need to find the rules. So to find like X4, then X1, so X4, then whatever the value of split we have chosen here, okay, that value, then X1, that value, then X2. So this is one of the rules. Similarly, we will have to find all the rules. Okay, so that is all the rules, and we'll have to work on it. Yeah. So this way we solve the decision tree. So let us look at a small use case. So the use case I've used is prediction of hospital readmission. Okay, so what is readmission? Okay, the hospital readmission is when a patient who is discharged from the hospital gets readmitted again within a certain period of time. Okay. Now, hospital readmission rates, okay, for certain conditions are now also an indicator of quality of hospital. If people are coming more often, okay, after getting treated also they are getting readmitted. So this shows that the hospital is not good. Okay. And it also affects the cost of care adversely. Okay, so it affects their cost of care. For this reason, okay, the Centers of Medicare and Medicaid Service, CMS, okay, they have established the hospital readmission reduction program, which aims to improve the quality of care given to the patients and to reduce healthcare spending on by applying payment penalties to hospitals. They have those hospitals, they have more than expected readmission rate. Okay, for certain condition, not for all the cases, for certain cases. Okay, although, so here we are trying to predict the hospital readmission rate for diabetes patients. Okay, although these diabetes patients, they have not been included in the penalty measure. Okay, but this program is going on adding new diseases to this list. Okay, so till 2018 the list was 6 basically. Okay, and you can see in 2011 American hospitals, they spend over $41 billion on diabetic patients who got readmitted within 30 days of discharge. So here also we can see a lot of money is being spent. Okay, so we are trying to also predict this so that this money or this budget could be somehow reduced. Now, being able to determine the factors that lead to higher readmission in patients suffering from diabetes, okay, and correspondingly being able to predict which patients will get readmitted in the hospital will help us save millions of dollars while also improving the quality of care. Okay, so with that in mind, we are building this on a Mediclaim data set. Okay, So I'll show you. Now we are looking at the EDA parts of this. Okay. So first of all, we saw there is an imbalance in the categories. So people who are not getting readmitted versus people who are getting readmitted. So we saw a very less number of people are getting readmitted. Okay. We also saw how much time do people spend in hospital versus how much time in before readmission. Okay. So we saw obviously time in hospital will be more than readmission time. Okay, but we saw here a skewed trend. Okay. We also try to find out what is the effect of age on readmission. Okay. So we saw the people who are around 40 to 80. Okay, we saw the highest value of readmission in the. Okay, and ethnicity also we saw. Okay, based on race. So we saw Caucasian people, they are getting more readmitted than African or African American than others. Okay, we also checked for gender ratio. So we saw more amount of females. Yeah, this is female. Okay, more amount of females are getting readmitted. Also, we checked for diabetes medication prediction versus readmission. Okay, so we saw the people who are having higher diabetes medication, okay, or are on diabetes medication are getting readmitted more than those who are not. Okay, then we model this data. Okay, so according to our model, we found accuracy is around 92%, precision is also 93%, and recall is 90%. So we got good, you can say, results for our model. Okay, we also did data modeling for to find out the important features. So you can see time in hospital is the most important feature which we selected here. Okay, as it is the output basically. Sorry, this is the most important feature for readmission rate. Okay, then discharge, then number of diagnosis, number of medication. So this is according to decreasing order in you can say importance. As per our decision tree, we got these results, and these are the importance values which we got. Okay. So let us go to the coding part. Let's see the coding. Okay, so the same thing. Also here we have just let me zoom it a bit. Okay. Now let us show you the data description. So here the data has columns like encounter ID, patient number, which is a unique identifier for a patient. Okay, race, which race this person belongs to, gender. Okay, age group. Okay, age group is grouped in year of 10, so 0 to 10, 10 to 20, like this, up to 90 to 100 we are having. Okay, then we are having weight in pounds. Okay, admission type, so it is an integer that corresponds to 9 distinct values, like we are having emergency, urgent, elective, newborn. Okay, similarly we are also having discharge disposition, which is also given an integer identifier, where we are having 29 distinct value, like discharged at home, expired. Okay, something like this. Admission source, here also we are having 21 distinct values, like physician referral, emergency room, transfer from a hospital. Okay, so 21 distinct values like this we are having. Time in hospital is the number of days between admission and discharge. Okay. Then we are having pair code, which is also an integer, which is also, encoded using integer identifier. Okay. Like admitting physician corresponds. It has 84 distinct values. Like, sorry, this is medical specialty. Pair code, it has around 23 distinct values like Blue Cross, Blue Shield, Medicare, self-pay Medicare. Okay. Then we have medical specialty. Under this also, this is also encoded using integer identifier. Okay. It has 84 distinct values like cardiology, internal medicine, family or general practice, surgeon. Okay. Then we also had number of lab procedures that has been performed, or number of lab tests that has been performed during the encounter. Okay. And number of procedures. Okay. Other than lab test, whatever procedures have been performed has been listed in this. Okay. So it is the numeric number of the procedure, total number of procedures performed. Then number of medications, so number of distinct generic names administered in the encounter. So what distinct medicines have been administered? Okay. Then we are having number of outpatient visits. Okay. Number of outpatient visits. Then number of emergency visits. So number of emergency visits to the patient in the year. Then number of inpatient visits, number of visits to the patient in the year preceding the encounter. Okay. Then we are having three diagnoses: the primary diagnosis, secondary diagnosis, and additional secondary diagnosis. Okay. So it has around 848 distinct values for 1, 923 for diagnosis 2, and 954 for diagnosis 3. Okay. So here we will be entering the number of diagnoses in the system. Okay. Next is glucose serum test. So here will indicate the range of the result. Okay. So like greater than 200, greater than 300, or none if test is not taken. Oh, sorry, not none. Or if the test was not taken, also we'll have to mention. Okay, A1C test. Okay, so it indicates the range of result, or if the test was taken or not. So A1C test. Okay, it has values like greater than 8, greater than 7 to represent greater than this percentage. Okay. Now change of medication. Okay, it shows if there is a change in any diabetic medication, either the dosage or name of the medication. Okay. So here values like change or no change is given. Okay. Then diabetes medication. Here we are giving whether they are having prescribed medicine or not. So values are like yes or not. Sorry, yes or no is being shown here. Okay. So here also we are giving the names of the medication. So total of 24 medicines are there. Okay. Then last we are having readmitted, whether the patient has been readmitted or not, or days of inpatient readmission. Okay. So let's go to the coding part. So here we started off by importing all the important libraries like PD, NP, Matplotlib, and Seaborn. So PD is used for data manipulation, NP is again for NumPy, numerical Python, and Matplotlib and Seaborn are for data visualization. Seaborn also has advanced visualization capability. From this, we now imported the diabetic data set. Okay, and we just saw the first 10 columns of this. Okay, so you can see these are all the columns. So this is basically transposed columns we are seeing. Okay, so these are all the records 0 to 9, 10 records we are having, and these are the columns, and these are the certain values of this column. Okay, so we are having all the medicine names, whether they took or not. So yes or no. Okay, then we saw the shape of this. So it was 1,01,766 rows and 50 columns. Okay, so these are the columns we are having. Okay, then we also try to find the missing values in the data set. So these are all the missing values. So race has some missing values, pair code has some missing values, weight has some missing values. Okay, so various EDA we are performing. Okay, so gender also we saw, gender also has missing values. So then we dealt with the missing values. Okay, so we dropped off the columns which are having higher missing values like weight, pair code, and medical specialty. Okay, so and those who did not have any missing means higher missing values. Okay, we treated them, we imputed the missing value. Okay, so there are certain drugs which have all record same, so zero variance column we dropped also. So these two are zero variance. Okay, all the values are same. Okay, we drop this zero variance column. Okay, next. Then we again check for missing values. So we saw no, there is no missing values. We also did some feature engineering. Okay, like we are having a feature service utilization. Okay, now this data it contains the number of inpatient, emergency room visit, outpatient visit. Okay, so we converted them into a single column. Okay, similarly, number of medication changes also we converted into a single column. Okay, and we re-encoded it to certain value. So you can see 2 is replaced by 1, 7 is replaced by 1, 6 is replaced by 5, 8 is replaced by 5. And we did this for admission type, discharge disposition, admission source. Okay. All these columns we changed, we encoded. Okay. So here also you can see we replace the gender with numbers, we replace the change, whether changed or not, with number. Okay. All the things we are encoding. Okay. So this is done now. And we check for readmitted value. Okay. And we also did here greater than 30, we change to 0, and less than 30 to 1. And if it is no, we also change it to 0. Okay, so we did some feature engineering here for various columns to convert it into categories. Okay, then we did data visualization. So we already discussed this in our slides. Okay, so here we can see. Okay, number of medication use versus readmission, gender of patient versus readmission, change of medication versus readmission, diabetes medication if they are having or not versus readmission, service utilization versus readmission. Okay, glucose test serum versus readmission, AIC test or A1C test versus readmission. Okay, and here we are trying to show the number of lab procedures versus readmission. So you can see it is clearly matching with that. Okay. Now, pre-modeling we did. Okay, so various this also you can say it goes under pre-processing only. Okay. So after this, so we did some pre-modeling here. Okay, so this is the last data we got, the data set we got. Okay. Okay, so this is sorry, this is the correlation map we got between various data. So time in hospital, number of lab procedures. So you can see the values here. Okay, so this is the value of correlation coefficient. Okay, the large value of correlation columns we have created as per all the encoding we have done. Based on that, a large number of rows or or large number of columns has been created. Okay, then coming to modeling part. Okay, so we did decision tree. Under decision tree, we found our our prediction to be accuracy was 0.92, precision was 0.93, and recall was 0.90. Okay, and we also took a look at various features. Okay, so here time in hospital was the most important feature for decision tree modeling, followed by discharge, disposition, ID2, and number diagnosis, total number of diagnosis, the total number of medications, total number of procedures. So these all features were important when we saw. I also did logistic regression to compare it with. Okay, logistic regression did not give us a good result. So you can see accuracy is around 0.61, precision is 0.63, and recall is 0.56. Okay, I also checked with an ensemble model. Okay, I did random forest. When I checked with it, okay, we got better values here. Okay, better than we can say a decision tree. Accuracy came out to be 0.94, precision 0.99, and recall 0.90. Okay, 90% recall, 99% precision, and 94% accuracy. And here, the most important feature in random forest we got was insulin, then discharge, disposition, time in hospital, then metformin, which is name of a drug. Gender also was coming up. Number of procedures, admission source ID number 7. Okay, and number of diagnosis also, and level 1 diagnosis, and number of medication. So these all were the most important features which we got from random forest. And when we compare these three models, okay, you can see we are comparing accuracy, precision, and recall. So random forest performed the best in all the three models. You can see, okay, accuracy wise, also precision wise, also recall wise. Okay, and the least performing model was this logistic regression. Okay, decision tree performed. Based on these two, decision tree also performed good. Okay, so this was our modeling on decision tree. Okay, and let me also tell you something about random forest. So random forest is a ensemble method. Ensemble method are methods in which we can say various weak models are combined together. Various weak models are combined to give a robust solution, to provide a robust solution. Okay, so here random forest, one unit or algorithm, it uses a unit as decision tree only. So it is a combination of multiple decision tree. Okay, random forest it is a combination of multiple decision trees. Okay, so this random forest gives us a better result than decision tree, as we can see here. Okay, friends, so we did our modeling, we did our theory part. Okay, so for tomorrow, we'll be learning neural networks. Okay, and we'll be seeing how hospital analytics, uh, in hospital analytics, how do we use this neural network? Okay, so here we'll be seeing multi-layer perceptron. Okay, so this will be the tomorrow will be our last session for this program. Okay, for this time. So yeah, thank you everyone for attending and have a good day. We'll meet again tomorrow.